Good morning, all of you. Reddy, Assistant Professor of Mathematics, Government Degree College, Ramannapet. Today, I will talk on divergence and curl of a vector field. This is an important topic on the Unit 3. First, I will define what is the meaning of the divergence of a vector and what is the curl of a vector. Divergence means suppose if u bar x y z equal u1, u2, u3 be continuously differential function, then w1 by w(x) differentiate partially with respect to x first coordinate w1 by w(x) plus w2 by w(y) plus w3 by w(z) is called degree of is called divergence of vector field u bar. It is generated by div u bar or del dot u bar. So suppose if u bar equal u1, u2, u3, then what is the divergence u? It can be defined just differentiate with respect to x partially first coordinate w1 by w(x), second coordinate with respect to y, third coordinate with respect to z partially. Adding these three, we will get the divergence. In other words, another definition, if u bar be a continuously differential function, then I dot w by w(x) plus z dot w by w plus k dot w by z is called divergence of vector field u bar, and it is denoted by w or del dot u bar. So del dot u here I dot w by w(x) means w1 by w(x), I j dot w by w means w2 by w, k dot w by w means w3 by w. So finally, divergence means simple, just differentiate first one with the coordinate with respect to x, second one with respect to y, third one with respect to partial, and adding these three will get the divergence. This is simple one. Suppose if div u equals 0, then the vector is called solenoidal. When you say a vector is called solenoid, when you say a vector is called solenoidal, if divergence u bar equals 0. So div u equals 0, then u is called a solenoidal vector. Can we define curl of vector field? Here we observe it. U bar is a vector, and but divergence u bar is scalar. And can we define curl of vector field? If u bar x y z equal u1, u2, u3 be continuously differentiable function, then mod e1, e2, e3 dou y by dou x, dou y, dou y, dou by dou z, u1, u2, u3. This is called curl of vector u bar, and it is denoted by curl u bar del cross. So we can find very simple determine e1, e2, e3. Dou by dou x del, we know that dou by dou x z bar, dou by dou y j bar, dou by dou z k bar, and u1, u2, u3. So simply you can find curl u bar, just determine e1, e2, e3 or I j k, I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, u1, u2, u3. So if you take like this, if u bar x y z equal u1 I bar, u2 j bar plus u3 k bar, then mod I bar, j bar, k bar, and dou by dou x, dou by dou y, dou by dou z, u1, u2, u3. This is called curl u bar. So finally, we write curl u bar equal to increment of I, j, k, dou by dou x, dou by dou y, dou by dou z, u1, u2, u3. So this is I bar into dou u3 by dou y minus w2 by dou z minus j bar into w3 by dou x, w1 by dou z, and plus k bar into w2 by dou x plus w1 by dou. Suppose if curl u bar equals 0, then the vector is called a divergential vector. So divergence is 0, then it is called solenoid vector. If curl u bar equals 0, then it is called divergential. What is the meaning of the Laplace scalar? If phi x y z is just twice differentiable scalar field, then del dot del phi, that is called del square phi, is called Laplace of. So del dot del phi is called the Laplace of phi. So can we define del Laplace of phi, del square phi, del dot del phi? That is the dou by dou x or dou phi by dou x, dou phi by dou y, dou phi by dou y, dou phi by dou z, dou phi by. Since del phi, what is that? Dou phi by dou x, dou phi by dou y, dou phi by dou z. You know that divergence means the differential first one with respect to x, second one with respect to x. Finally, we are getting dou square phi by dou x square, dou square phi by dou y square, dou square phi finally. So what is the del square phi means? Finally, del square phi means del square phi by del x square, del square phi by del y square, del square phi by del z square. So this is called the Laplacian of phi. So finally, so finally, uh, if u bar equal u1 u2, then divergence of u bar means just differentiate first quantity with respect to x, second one with respect to y, third one with respect to z, and adding this w1 beta x. So first one with respect to x, second one with respect to y, third one with respect to z, partially, and adding these three will get the divergence. Curl means just simply determinant of e1, e2, e3, dou by dou x, dou by dou y, dou by dou z, u1, u2. You see some problems on this two. First problem, find the gradient del phi and the Laplacian del square phi for the scalar field phi equal x square plus xy plus yz square. So here let phi is equal to x square plus xy plus yz square. What is dou phi by dou x? So dou phi by dou x is equal to 2x plus y. Dou phi by dou y equal to here with respect to x partially divided 2x x square for xy y into 1 y yz square 0 because yz are constants. Dou phi by dou y means with respect to y, x square is 0 for x, y, x, and y, z square, z square. So, and dou phi by dou z is 2yz. Finally, and again, differentiate with respect to x, dou square phi by dou x equal to 2, dou square phi by dou y square equal to 0, dou square phi by dou z square equal to 2. So, finally, grad phi means 2x plus y, comma x plus z square, 2yz. So, del square phi means dou square phi by dou x square, dou square phi by dou y square, dou square phi by dou z square. So again, here the square phi by the x square is different respect to x partially two times. We get two. First time we are doing 3x plus 1 and then we are getting 2 plus 0 plus 2. That is 2 plus 2. Another important problem C. Another important problem. So find the gradient Laplacian of phi equals sine kx sine ly e power expansion root k square plus s square z. That is e power x k square plus s square z. So here like phi is equal to sine kx sine ly e power root of k square plus l square z. So first we know that what is the grad phi is the dou phi by dou x comma dou phi by dou y dou phi by dou z. The Laplacian del square phi means we know that dou square phi by dou x square plus dou square phi by dou y square plus dou square by dou z. First we find with respect to partially derivative with respect to x, dou phi by dou x. Here y and z are constants. So sine kx, derivative of sine kx is the k cos x. Kx is two are constants. You can write this dou phi by dou x. K cos x sine ly e power root of k square plus l square z. This is like a into sine kx. Like this is constant sine ly e power root of k square plus l square z. You know that sine kx partial derivative is k cos x. And again differentiating again with respect to x partially. Dou square phi by dou x. Again differentiating, we are getting cos kx square partially derivative with respect to x is minus sine kx, and for kx is k. Already k is there, k into k square. We know that dou, we know that dou by dou x of cos kx is the so dou square phi by dou x square. First time with respect to k cos x, and again for cos kx minus sine kx into k into k square. Again similarly dou phi by dou y. So these two are constants. Sine kx equal root of k square plus l square into z is constant. So for cos ly, sine ly, for sine ly with respect to y is l cos ly. And again with respect to y, dou square phi by dou y square. For cos ly, we know that L sin Ly. So L into L, L square minus L square sin kx sin Ly e power root of k square plus s square into fact. So this is like dou phi by dou y, dou square phi by dou square. Differentiate with respect by two times. First one time if we do sin Ly, we'll get L cos Ly. Again, we're doing with respect to y for cos Ly, we know that minus L sin Ly. So minus L square sin kx sin Ly e power root of k square plus h square into z. Again, differentiate with respect to z. These two are constants, sin kx sin Ly. We know that this is like e power az. We know that what is the derivative of e power az with respect to z is a simple a into e power az. In case of a, your root of k square plus l square. So e power, and this is root of k square plus l square, e power root of k square plus l square z. This is like e power az, e power az with respect to z. Derivative is a into e power az, therefore root of k square plus l square into e power root of k square plus l square. And again, differentiate with respect to z again. So again, we are getting another, this is like again e power az, and another we get to the k square plus l square whole square. Already one root of k square plus l square is there. So into root of k square plus l square whole square. So finally, we are getting sin kx sin L by k square plus l square. So we can write here, you know that e power. So for if you do one time e for az, this is we are getting like a into e for az, that is root of k square plus l square and e power root of k square plus l square. And again we are doing k square plus l square root of e power root of k square plus l square. And see another one. What is the grad phi? Just simple. Dou phi by dou x, dou phi by dou y, dou phi by dou z. So here we know that dou phi by dou x is k cos kx sin Ly e power root of k square plus l square. This is L sin kx cos Ly e power root of k square plus l square. This is sin kx sin Ly root of k square plus l square e power root of k square plus l square. Z. So what is the here del square phi is the, we know that dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z. So we can write like this, say dou square phi by dou x square minus k square sin kx sin Ly e power root of k square plus l square. What is dou square phi by dou y square? This is L square sin kx sin Ly e power root of k square plus l square. And dou square phi by dou z square is k square plus l square sin kx sin Ly e power root of k square plus l square. Taking common sin kx sin Ly e power root of k square plus l square or minus k square. Taking common this, here minus k square, here minus l square, here plus k square plus l square. 5 to 0, therefore phi satisfies Laplacian. One important problem. Another is find the divergence of the vector field u bar equal to r. You know that r bar means xi plus yj plus zk. This can be as xyz. What is the, this is the xyz, this is u1, u2, u3. You know that what is the divergence of u bar in definition? First coordinate with the differential with respect to x, partially first coordinate with respect to x, second coordinate with respect to y, third coordinate with respect to z, partially with the adding these three. So first coordinate is x with respect to x, second coordinate is y with respect to y, third coordinate is z with respect to x. You know that dou x by dou x is 1, dou y by dou y equal to 1, dou z by dou z equal to 1. Finally, we are getting 3. So the divergence of u is equal to, last time this problem came. Long question. Find the both divergence curl of the vector field u bar equal to y comma z comma x, and the second one u bar is equal to x y z comma z square comma x minus z square comma x minus. Let u bar equal to y comma z comma x. That is the u1, u2, u3. Here See here, W. So W is a, so here y is z x. The first coordinate is y differential with respect to x. Second coordinate is z. Third coordinate x. First coordinate W1 by W x, W2 by W, W3 by W. First coordinate is y differential with respect to x. Second with respect to y. Third with respect to z. This is partial derivative with respect to x. Y is constant. Here z is constant. Here x is constant. Because this is with respect to y. So 0 plus 0, that is the curl U bar means you know that E1, E2, E3. Dou by dou x, dou by dou y, dou by dou z, U1, U2, U3. What is U1? First coordinate y, second coordinate z, third coordinate x. So E1 into, this is the E1 into dou y by dou y of x minus dou z by z minus E2. So minus E2 into minus E2 into here this is y. Dou by dou x, dou by dou y, dou by y z x. So dou by dou y of x is the 0, dou x by dou y is 0, dou z by dou z is 1, minus E2 into dou x by dou x is 1, or dou z by dou y by dou z is 0, and plus E3 into dou z by dou x of z is 0, or dou y by dou y that is 1. So we can write this is minus E1 minus E2 minus E3. This is minus 1 comma minus 1 comma. This can be also written as E1 is the I bar, E2 is J bar, E3 is K bar, minus I bar minus J bar minus K. And second one, U bar is XYZ, Z square X minus Y. Here U1 XYZ, U2 is Z square, U3 is X minus Y. You know that the divergence means differentiate. First one, differentiate first one with respect to X, second one with respect to Y, third one with respect to Z. So first coordinate is XYZ, differentiate with respect to X. Second coordinate is Z square, differentiate with respect to Y. Third coordinate is differentiate with respect to partial. Simple divergence, finding divergence of U bar is very simple. Just differentiate first coordinate with respect to X, second one with respect to Y, third coordinate with respect to Z. You know that the derivative of XYZ with respect to X partial derivative YZ into 1, YZ. Here Z square is constant, Y with respect to Y. Partial derivative with respect, that's why Z square is constant, you can get 0. And here it is a partial derivative with respect to Z, XY are constant. So X minus for derivative is 0. You know that constant of a derivative is 0. Derivative with respect to constant is 0. Constant of derivative is the 0. So the u bar equal to y. So divergence is very simple. The differentiate first one with respect to x, second first coordinate with respect to x, second with respect to y, third with respect to z, respectively, partially with respectively. And adding these three will get the divergence. Curl means del cross. We know that the formula E1, E2, E3, dou by dou x, dou by dou y, dou by dou z, x, y, z, z square, x minus. So E1 into dou by dou y of x minus 1. You know that for x is 0, for y minus y minus 1. And dou by dou z of z square, that is 2z minus 2z. Minus C2 into dou by dou x of x minus y, 1. Dou by dou z of x y, just equal to z, x, y. So 1 minus x plus E3. Dou by dou x of z square 0, dou by dou y of x y z is the y x z. So finally we are getting minus 1 minus 2z E1 plus xy minus 1 d2 minus xz d3. So finally we can write curl u bar as minus 1 minus 2z by xy minus 1 minus x. Okay. And so this is the divergence means very simple. Divergence, finding divergence for first coordinate, differentiate partially with respect to its first coordinate, second with respect to y, third coordinate with respect to z. Adding these three will get the divergence. Curl means this is determined. Second one. The important problem. This is one important problem. Uh, so if u bar equal y square z minus z square sin y plus 2x y z plus 2z cos y plus y square x is rotational. Find the corresponding potential function. Hence, find the value of the line integral of u bar along the curve x equals sin pi t by 2, y equal t square minus t, z equal t power 4, and 0 less than equal to t square, t less than equal to 1. We know that when we say vector is called rotational vector, if divergence u bar equals 0, if divergence u bar equals 0, then the vector is called this is called rotational vector. Let u bar y square z minus z square sin y plus 2x y z z cos y plus y square x. So curl u bar del cross u bar, that is the u modulus of e1 e2 e3 dou by dou x dou by dou y dou by dou z y square z minus z square sin y plus 2x plus z 2z cos y plus y square x. So we know that curl u bar means e1 e2 e3 dou by dou x dou by dou y dou by dou z u1 u2. So E1 into dou by dou y of 2z cos y by square x. We know that for 2z cos y, for cos y minus sin y, so minus 2z sin y. For y square x, 2x minus of dou by dou z of minus z square sin y plus 2xy. For z square minus 2z sin y minus plus 2z sin y. And for x, for 2xy, then we are getting 2xy. So before minus is there minus 2xy. And again minus c2 into c2 over the x of 2z cos y plus y square x, 2z cos y plus y square, and the dou by dou z of y square z. You know that for 2z cos y it is 0, and for y square x, y square, and again here minus of for y square z, y square into 1, because it is a partial derivative with respect to z, y square is constant for z1. So we are getting finally y square minus y square plus c3. What is e3? The dou by dou x of minus z square sin y plus 2xy. Minus dou by dou y of y square. You know that dou by dou z of minus z square sin y is a minus z square sin y is this is 0 with respect to x. For 3xy z with respect to x 2yz, and for y square z 2 minus 2yz. Finally, you are getting u1 0, u2 0. Curl u bar equals 0, therefore u bar equal to 0. U bar curl u bar equals 0, therefore u bar is commutative. So whenever it is conservative field, that means it has a potential function. That means u bar equals some del phi. So for some function, so here u bar is y square z, comma minus z square sin y plus 2x y z, 2z cos y plus y square x. We know that what is the ground phi? Dou phi by dou x, dou phi by dou y, dou phi by dou. So comparing these two, dou phi by dou x equal to y square z, dou phi by dou y equal to minus z square sin y plus 2x y z, and dou phi by dou z is 2z cos y plus y square. So whenever curl u bar 0, then the vector u bar is conservative. So therefore u bar is equal to del phi x for some function phi, for some function. So we can write dou phi by dou x equal y square z, dou phi by dou y minus z square sin y plus 2x y z, dou phi by dou z 2z cos y plus y square. From this, so, integrate 1 with respect to x. So integrating 1 with respect to x. What is 1 here? Dou phi by dou x this can be written as dou phi by dou x differential with respect to x. This is the y square that is constant. Integral dx is x. So we are getting xy square y square zx is xy square z. Plus it is the y z are constant, right? It's some y z. And the second one integrated with respect to y. Second one with respect to y. Can respect to y. Here for we know that integral minus sin y is a cos y. And for 2xyz with respect to y, y squared by 2 xy squared z. And we are getting finally this is like this second one. Z square cos y plus xy squared z plus h2 zx. Because my integral minus sin y is cos y. And for 2y, y squared by 2 to be cancelled. H2 z of x. And integrate 3 with respect to z, we get the third with respect to z. We get for integral 2z z square by 2 for integral z square by 2 will be cancelled. This is z square cos y, and y square into integral 1 dz. So y square x z. So square z. So this is just h3xy. So comparing 1 to 3, we are getting hyz equal to z square cos y. This is 5 equal to z square cos y plus xy square z. Comparing these 3, 4, 5, and 6, we are getting hyz equal to xy square z plus k where k is cos. So finally, we are getting u bar equal to del phi. U bar equal to del phi, that is the dou phi by dou x, comma dou phi by dou y, dou phi by z. Dr bar equal to dx divided dz. U dot dr bar equal to del phi dot dr bar. So that is dou phi by dou x dx because the del phi dot dr. Dou phi by dou x dx plus dou phi by dou y dy dou phi by dou z. This is the d of. So finally, integral c u dot dr bar equal to 5002101. So that is the given derivative will be cancelled. That is 5xyz. And here you observe curve is x equals sin pi by 2t, y equal t square minus t, z equal t power 4, 0 less than t 0. At t equals 0, x y z equal t 0, sin 0, 0. This is 0 minus 0. This is 0, 0, 0. T equal to 1, sin pi by 2, 1. This is 1 minus 1, 0. This is a 1. So points are end points are 0, 0, 1, 1, 0. Substitute 0, 0, 1, 2, 1, 0, 1. So phi of 1, 0, 1 and phi of 0, 3. So here phi of x y z equals z square cos y plus x y square. So finally, this is another problem, important one. Just only here. Differentiated with respect to x, we are getting y square z dx. That is y square z into x plus function of yz. Why? Because yz are constant. Here with respect to y, minus sin y is cos y. And with respect to y means y square by 2 is the 2 will be cancelled. X y square z plus function of zx. And with respect to dou by dou with respect to z, for z is z square by 2, we are getting z square cos y. Y square x dz means y square x z. So here written because yz are constant, I have written here x1 yz. Here zx are constant, j2 zx and xy are constant, 3x. We lost this. Find the angle between the sphere and the cylinder where they intersect. That the given sphere is a x square plus y square plus z square equal to 2. And the given cylinder x square plus y square 1 plus z square plus 3 equal 1. That is z equal plus y plus x square plus y square. So therefore, the point of intersection of given sphere and the cylinder are they are intersecting x square plus y square equal 1, comma z equal plus. Let the equation of sphere S is f of x y z equal to x square plus y square plus z square plus 2. And equation of cylinder C is f2 x y z x square plus y square minus 0. So first I have to find the unit normal to the sphere. Del phi 1, del phi 1, del f1 by mod L. So here f1 is the x square plus y square minus 3 plus z square minus 2. Dou f 1 by dou x is 2x because these two are 0. Because with respect to x, dou f 1 by dou y is 2y, dou f 1 by dou z 2z. So by mod del f1 is the root of a square plus b square plus c square. Root of 4x square plus 4y square. Of 2x whole square plus 2y whole square plus 2z whole square. Finally, we are getting n bar equal to x y z by root of x square plus y square. And again, del phi 2, del f2, dou f2 by dou x. This is f2. This is 2x, dou f2 by x. Dou f2 by dou y 2y. Dou f3 by dou z. Dou f2 by dou z is 0. 2x 2y. Mod del phi 2 is the root of a square, a1 square plus a square plus a2 square. 2x whole square, 4x square, 2y square, 4y square plus 0. Here 4 LCM, root 4 is 2, 2 into root of x square plus y square. So the unit term on 2. Here there is a del f2 by mod del f. Therefore, n2 equal to xy0 by root of x square plus y square. You know that the angle between the given surfaces where they intersect is same as the angle between their normals at the point. N1 dot E dot B is x into x square plus y into y square, z into 0, 0. By, you know that the root of x square plus y square is 2, x square plus y square is 1. There is some important problems of love them. Practice these problems.